Namaste. So myself Shivanandappa H Doddagoudar. In this video lecture, I am going to take a BSc 5th semester Mathematics paper 3 Statics and Laplace Transforms. In that paper, I am going to deal with that Laplace transforms. Now this is the session number 43. In this session, we are going to discuss the Laplace transforms of derivatives. Okay. First, we should discuss this derivative of the transform property it is. See this, we will take that one in the form of theorem. If L of f of t is equal to f of s, then L of t to the power n into f of t is equal to what it is, minus 1 raised to n dn divided by ds n f of s, where n is a positive integer. That means here this property is also known as a multiplication by t. That means L of f of t is given, then we have to take the Laplace transforms of multiplication of t with that f of t. We are going to deal with that one here. Now, we shall prove this by mathematical induction. Now, by definition, you know L of f of t is equal to 0 to infinity e raised to minus st f of t dt. That can be written as capital F of s. Now, we should differentiate this one with respect to s. D by ds of f of s is equal to d by ds of 0 to infinity e raised to minus st f of t dt. By applying the Leibniz rule for differentiation under integral sign, d by ds of capital F of s, you keep that one as it is, 0 to infinity integration as it is. What is the differentiation of e raised to minus st with respect to minus s? That is e raised to minus st into minus t f of t dt it is. Now, multiply throughout by minus sign, minus 1 into d by ds into f of s is equal to 0 to infinity e raised to minus st t into f of t dt. Now, by definition, that right hand side quantity we can write it as a L of t of f of t. Now, we are getting in this step L of t into f of t is minus 1 into d by ds of capital F of s it is. Here t to the power 1 is there, therefore minus 1 raised to 1 itself it is. That can be written as minus 1 into d by ds of f of s it is. Now, this verifies the result for n is equal to 1. Now, we can take the result is true for n equal to k, n equal to k. Now, that is why you can write it as a minus 1 raised to k d raised to k divided by ds raised to k f of s is equal to 0 to infinity e raised to minus st t to the power k into f of t dt. That is equal to what it is, L of t to the power k into f of t. By definition, we are getting. Now, we should differentiate this one more time with respect to s. Minus 1 raised to k, you keep it as it is. Derivative of d to the power k ds raised to k is d to the power k plus 1 ds k plus 1 f of s is equal to 0 to infinity, and you have to differentiate that e raised to minus st again in the similar way what we did in the previous step, 0 to infinity e raised to minus st minus t. They keep that t to the power k into f of t dt as it is. Now, again multiply throughout by minus sign. In the left hand side, what we can get, minus 1 raised to k into minus 1 means minus 1 raised to k plus 1 we are getting. Derivative of d of k plus 1, d to the power k plus 1 divided by d k plus 1 f of s is equal to 0 to infinity e raised to minus st. You have to multiply the t with the t to the power k, we can get t to the power k plus 1 f of t dt. That can be written as L of t to the power k plus 1 f of t. Now, by putting k plus 1 is equal to n, we can get L of t to the power n f of t is equal to minus 1 raised to n d to the power n dsn f of s. Now, that means the result is true for n is equal to k plus 1. Hence, the result is true for all positive integral values of n. Now, we can take the examples on this one. It is find L of t into cos at. Now, by looking this example itself, we can come to know that it is of the Laplace transforms of derivative form, that is multiplication of t is there with that cos at, multiplication of t is there here. Here f of t we can take it as a cos at. First you should find the Laplace transform of that f of t, that is L of cos at, that is s divided by s square plus a square, that is f of s. You know L of t to the power n f of t is equal to what? Minus 1 raised to n d to the power n divided by d to the power sn f of s. Now, in this example, in the present example, power of t is 1, that's why n is equal to 1. Therefore, L of t into cos at is equal to minus 1 d by ds of f of s, that is minus d by ds of s divided by s square plus a square. Keep that minus as it is, and you have to differentiate that one using u by v method. We can get what it is. Simplify that one, we can get s square minus a square divided by s square plus a square, the whole square it is. One more example. See this example also it is. Find L of t cube e raised to minus 2t. Here f of t is equal to e raised to minus 2t. L of f of t is equal to L of e raised to minus 2t. First we should calculate that one is 1 upon s plus 2 it is, that is equal to f of s. Here no doubt it is also of the type Laplace transform derivative. Here in this case n equal to 3 here. Now that's why L of t to the power 3 e raised to minus 2t is what it is, minus 1 raised to 3 d raised to 3 ds raised to 3 f of s it is. That means you have to differentiate that f of s 3 times. Minus 1 raised to 3 means minus it is. You have to differentiate 1 upon s plus 2 3 times. Now that will give us a 3 factorial divided by s plus 2 raised to 4 it is. Now totally it becomes a that what it is, 6 divided by s plus 2 raised to 4 it is. Now in the similar way, try to solve these examples yourself. Now one more theorem it is, L of f, if L of f of t is equal to f of s, L of integration, that is 0 to t f of t dt is what it is, f of s divided by s it is. Now see that example here. I have not solved these examples. By looking that above theorem, by using that above theorem, we can do this one very easily. L of 0 to t sin t dt it is. Okay, here f of t is sin t. First you should calculate the L of f of t. L of f of t means L of sin t. L of sin t is what is here, 1 divided by s square plus 1. Therefore, L of integration 0 to t sin t dt can be written as a what it is, 1 upon s into f of s, that is 1 upon s into 1 upon s square plus 1. You can do these examples yourself. Try to solve that one more, that example also yourself. Now these are some multiple choice questions. Try to solve and find out your answer choices yourself. Now these are the references here. Okay, thank you very much.